got audio? Alright. This music's probably really loud. Alright, what's up? So, I've been spending, I don't know, a couple days trying to learn about how file systems work so that I can implement an actual file system. Thus far, I've just been using tar as the file system, which was great for simplicity of use and like focusing on what's actually critical to an operating system, but not useful for, you know, being a good file system. So I read in this book OSTEP, which stands for Operating System in 3 Easy Step Parts or something. What is this? Yeah. Let me pull it over. Yeah, that's not helpful. I'm gonna get the link. That's what we want. So there's an online version, but this is the book. There's this part on persistence talks about, you know, basically like describes in file systems and stuff, and this one, file system implementation, talks about a specific one called the very simple file system, VSFS, and that's the one I'm gonna implement. So the structure, I have my own little diagram. Mine's basically the same as theirs except bigger. They only have like a tiny little 64 block disk image for the file system. And mine is much bigger. So the idea is to basically have, you know, a unit called a block, which in this case is 4 kilobytes, and just organizing data into these different blocks in certain ways. You know, so this is how it is. First you have a boot block, which we're not going to use at all, but you know, as I'm researching file systems, this is where the bootloader would typically be. Since we're using QEMU and like avoiding having to do all that, you know, basically the kernel just, or sorry, QEMU just like jumps to the kernel. You tell it like, you know, put the kernel at this memory address and it just jumps there. We're not going to use the boot block, but then the super block just holds metadata about the entire file system, like, you know, how many blocks are there, where does the inode table start, where does the data region start, things like that. Is this music still too loud? Okay, so I'll crank it up if something sick comes on. Okay, so that's a super block. Then you have these 2 structures that are bitmaps that just tell you if the inodes or data blocks are in use. Inode table is just a flat array of inodes, and then the data region is where all the file data, like all the user data is. Yeah. So, you know, inode is like a very Linux thing, but like every file system will have some like metadata structure for files. The interesting thing about inodes is that they don't store the name. The names of files are stored in the directory in these so all a directory is, like the data that's in a directory that's going to live in the data region, is just a list of essentially like inode numbers and names associated. So that's where the names live. The reason for this apparently is to enable hard links to be a thing. So you can have if you just add another inode name pair to the directory and it has the same inode as some other name, then those refer to the same file on disk. That's what a hard link is. Yeah, so I guess that's very quickly what I've been researching and figuring out, and now what I want to do is implement this file system. And so the first step I'm thinking is you're going to have to write, you have to create a disk image that you can load in, right? So I basically have to write some I have sort of a testing file system that's just, some random little test files in there, and so we need to write that into this format. So I spent some time trying to figure out how I'd want to do that, writing out, these data structures that you'll need and sort of pseudo coding out what you need to do yesterday. So going to implement that today. So this is the file structure, the directory structure right now. So this is going to be like the root directory. There's 2 directories in there and 1 file, and then it just continues down from there. It's just a directory tree. So the idea is to basically maintain a list of inodes, and then this thing called a disk image entry, which is what I'm calling you're when you're traversing through. Okay, so let me back up. So this is going to be a separate program whose input is just a path to some directory. And given that directory, it will traverse the directory and write out what it needs to in this file system format. And so you're going to traverse this. I mean, it's a tree structure, so you traverse the tree structure, but for writing it out, it's easier to just have like a flat list of like entries where it could be, it's basically a discriminated union type of thing, but I don't have a just it's a megastruct basically, right? Where you switch on the type to figure out which fields are in use. Right, so you have directories and files, which are both disk image entries, which will contain all the data you need to like insert one of them into the disk image. So for files, you just need a path, because from that you can figure out the size and read the data in. And then for a directory, you basically just need a list of inode and name pairs, right? Which is what this is. So this there is like all of the links, which actually, yeah, I was gonna rename this like a dir link, because I was starting to get quite confused with entry. Like you have disk image entry versus disk dir entry. Naming is quite hard, but link is a good name because that's like literally what these are in Linux land, Unix land. We should probably replace that everywhere. Dir entry with dir link. Yeah, so So the idea is given a path to some directory, build up an inode table, and then build up these like disk image entries, and then you can write them to disk. And what that is just like iterating through each of them and inserting the bits where the bits needs to go. So, you know, the first step is going to be traversing this here directory structure, which this traverse dir will do. So given some path, you need the parent inode because each directory will have the entries dot and dot dot. Like this is you and this is your parent. So you need to pass that in. And then these are just the arrays that you're going to fill out. So since this is a separate, this is just going to be a standalone program, I can use a bunch of like, it can be nicer to use than it is in the kernel. So I'm thinking that I might, you know, have a little stretchy buffer thing so I can have a dynamic array type of situation. You know, I have other projects with a stretchy buffer implementation I can use. That's what these buff things are. This is just an annotation. This is a stretchy buffer, not just a regular pointer. Just to make things easy. So, I'm gonna try to refresh myself on what I wanted to do. So as you traverse a directory, first thing you do is create a new inode, put it in the inode table. You only know the type right now. Hey babe. You don't know the size or where the data blocks live. Thank you. Sweet. Just got a delicious smoothie. My girlfriend is the shit. Right. So you insert a new inode. You're gonna create one of these disks there, which is just the, you know, a list of links. Create entries for dot and dot dot, and then read all the entries in this directory. Right. So readdir. I have an implementation of a readdir that I wrote in the compiler that I wrote. So I'll just pull that over, but it basically just reads all the entries in a given directory, tells you their type and all that jazz. So for each entry, if it's a directory, just recurse down into it. If it's a file, we create a new inode and a new disk entry, disk image entry. Easy as. So yeah, it's just a simple tree traversal. It's pretty straightforward. The only subtlety was like, in order to create one of these like links, you have to have an inode already. Like you need the inode number, and so that's why we're having this return the inode number. So it's like what do you call that? Like the tree traversal order, is that like in order? Well, actually that's interesting too, because there's like a difference between the order of the inodes and these entries, but it doesn't really matter. I just remember having a little bit of trouble with that yesterday, but sorted it out. Alright, so maybe the first thing to do is see about pulling in this readdir implementation from the compiler. Yeah, so let's do that. It's gonna be here. So this is the Windows version. It's gonna be different for Windows and Linux. Should I split those out? We'll just start with Windows for now. I'm just using Windows for now. And we're gonna need to pull in the stretchy buffer implementation, which I don't know if I want to use the version that I created for the compiler. I mean, it's really Per Vonson's implementation because it's from Bitwise. But it uses the arena. Where did I go? What the fuck is happening? Probably here. Stretchy buffers, okay. Oh yeah, and this is back when I was calling it dynamic array. I don't like that. I like buff nowadays. Wait, don't I have another one of these somewhere? Where else did I use that? I mean, I think I did it in my linear solver. Maybe not. Alright, we'll pull it from, or maybe it was here. Yeah, here we go. Nope, this one's using just malloc and realloc, which is fine. We just won't have pointer stability, which I don't think we need for that, so let's just pull this over. It's pretty simple. Honestly, I'll throw that up here. This is sick. Fuck that. Alright, apologies. Alright, so I think we might have a path max already, like, near, or maybe it's, where is it? Path max? Should probably in common, and it was only 100 because we're using tar, but we're switching away from that. Alright, so we'll use that. eventually, but for this one, we'll just call like 256. Yeah. I guess that's already a thing sometimes. We're not including any of the... Well, I guess that makes sense. We're gonna actually use like C standard library shit in here. We'll do that. Actually, hold on. Alright. Let's switch to some... Should be pretty quiet. Alright. Alright, well, since we're using malloc and stuff, we're gonna need like stdlib probably. Malloc's in stdlib, right? Yeah. Okay. Cool. We got a stretchy buff. Alright, I don't like this. Once again, now we have these confusing, like, dir entry, disk image entry, dir link. There's so many different representations of what a directory is, right? Like, so this one just has, like, the base name of the path and the file name, its size, and whether or not it's a directory. Maybe it's okay. We'll just call it dir entry. It's just so confusing. Alright, we got stir comp in there. I mean, honestly, we should just be letting the compiler tell us what we need. Which, that's what I'll do after this. Alright, let's set up a... build scripts. If not exist, build. Make their build. Do I do it like that or like that? I don't remember, it's been a while. Push the property. What are we gonna do? Like CL, no logo. Yeah. W4 maybe. Warnings or errors. Alright, what do we want to call it? VSFS disk image? Maybe? I don't know. Except you don't want that. You want to do it in like the directory. Hold on, what is it? It's like DP0. God, every time I forget how this fucking works. Oh, I got another project. Like the compiler maybe. Build. Basically this. FE. And then sure. Just take this. I guess the only problem we're gonna run into is we have that relative what's it called? Relative path to a header here. Can we just do this? Like I mean just include dot dot. I don't know. Include the parent. Alright, so let's do this. Let's go into here. Let's do this. What the fuck is happening? What's happening? I'm so confused. It's just freaking out. Why? are these not happening? Why is it not compiling? Like F5 is not compiling from here for some reason. No lines in buffer. What the fuck is going on? So, yeah, we do that. Is that it? What the fuck? What the fuck is happening? This should just run, right? So... What the fuck? There we go. Okay, what? Okay, now things are working. Fuck. Right, so we're including, like, the... common. Honestly, it's just for fucking U32, honestly, isn't it? Well, we're including the file system, which then includes common. This is why header files are retarded. The shit out of my throat. Alright, I'm just gonna like directly pull in like the one or two structs that we need instead of dealing with like trying to use all of the kernels like includes and manage all of that. So I'm gonna do that real quick. Alright, so yeah, we're missing some functions that reader uses, path copy and path join, so I'm gonna pull those over and crank this because this song's fire. I saw these dudes play in concert when I first moved out here. They're fucking sick. song's called Deadroot Stirring. Alright, we're finally compiling. Alright, so let's start doing this shit. So... No. What the fuck is this? Why is this green? Okay. Thanks, fam. This one too? The fuck? Okay. So, one important thing to note is that inodes are going to reserve 0 for like a non-existent inode, so it's going to start at 1. I thought I had a root inode number, yes. I mean, it's really not ideal to be copying these over. You just want to reference the thing you're gonna use, so if it changes in one place, but I can, I'm gonna have to like restructure the stupid fucking header files to do that, so I'll do that later. Um, so first let's just get the argument right. So you need one argument, which is the path. If it's less than 2, usage, this, directory path. If you have an argument, use that as the directory path. Yeah, make empty entries. So you want a dummy entry. In case it ever is bigger. Into inodes. An empty disk inode. Does that work? I think that works. Alright, do we have entries? Does it return blocks written? I don't know, I just assert that I wrote anything at all, but for now it's gonna be 0. Just don't call that yet. Okay, so traversing the directory. So first thing, insert a new inode into the inode table. So the next inode num is going to be the current length. Inodes. Which, do we have this? Sorry. Yeah, unsigned. We did sign by default, so. Then we can add to inodes a new disk inode whose type is, or sorry, we called it inode type now. Yeah, whatever. Inode dir, which we also don't have. Okay. Create a new disk there. What's in those things again? Alright, hopefully that's everything from here. Actually, no, we're gonna need this. Maybe we'll need this super block. Okay. Also, I don't know, my head's over here somewhere, right? So try to not be programming there. Okay, a disk there. So we're creating a disk there. Honestly, since, yeah, this is dumb. Since we're using stretchy buffers everywhere, this should just be a stretchy buffer. So you just have a buffer of dir links. And we'll call that disk dir. Yeah. So then we need to create entries for I'm just gonna call this Sterling. How easy? That's not gonna be very easy to do that. So we'll do this. We're gonna make a new. I like doing it like this. So inode num is inode num. Entry size, name size, and name. So we're doing dot and dot dot, right? The name size is 2. The entry size is gonna be the name size rounded up to the nearest multiple of disk dir entry men. We can figure out the like generic way to do that later, but now since we know disk dir entry men, we'll call it dir link name dir link min size. It's like the name minimum size, so I just don't want it to be crazy long. Dir link name min. Whatever. Dir link name min. Or yeah, entry was actually right there. Sterling Countryman. So that's dot. Dot dot. Gonna be 3. I mean, does it matter? We could just do it like this. It really doesn't matter, but... Alright, dot and dot dot. Except the inode number is the parent inode number. Right? Okay. Now we can do a reader. So how does that work again? I really need to do a ctags so that I can just jump to shit. It's a pointer. Reader path. Right, so we have this is actually a buffer. A stretchy buffer. Okay. Entries. Alright. Loop through the entries for each entry. If... How much do we use it? Do we need a reference to it? Probably. Entry is entries at my... We are now taking a pointer to a thing in there, but it should be okay because we're not changing the size after this. Although it's so small you could pull it by value, but whatever. Fuck it, we'll just copy it. Well, no, it's copying the string then too. We're not copying it. Okay, if entry is dir, well, entry inode verse dir with the path. We're gonna have to build that. Traverse dir subpath inode num inodes entries. See, we got entries here, which are disk image entries, and entries here, which are dir entries. It gets confusing. Otherwise, it's a regular file. This needs to be available. I guess child I know number. Vim is weird sometimes. It's like not okay. Otherwise, the child inode number is gonna be this. And then we can say we add a new inode. It's gonna be of inode type inode file. Okay, then we insert a new link for this. Alright, so this is one entry in this directory. It's either a directory, a subdirectory, or a file. In either case, we now have an inode number for it, and so we can create this link. So it's gonna be like this. Link. The inode num is child inode num. The name size is gonna be Sterling, I guess. +1 of whatever the path is. And then entry size is gonna be something like round up. Or, I mean, I guess this isn't a lineup. The name size, which means you need the name size. So we do this. Okay. So what's the name? You need the full path, right? So let's build that now because we need it here too. So the entry is that, damn it, we're gonna have to like copy the name and that's fine. Okay, wait, what does path join do again? Right, so you just need something like this. Subpath. Something like this. Does path drop the zeros in for me? I forget. It does. At least if you path copy. We'll deal with it if there's an issue. I mean, what I'm debating is whether I should do this. I mean, it's only 256 zeros, so fuck it. It's just gonna mem set that. So the subpath, actually, we can just do this. Path copy. Subpath. Entry base. And then path join. Name. So the way that readdir works, it returns dir entries that have the base, which is like the path without the name. So if you have like 1, 2 file text, the base is 1, 2, and then the name is file.text. So that's that. We got a subpath now. So that's fine. But we need the name. So the name... Right, Sterling doesn't include the null character. I'm like 99% sure, but we'll just check. The number of characters, not including the null character. Perfect. So we're gonna have to figure out this align up dealio. Align up name size by that. And then the name is gonna be, what do you do? Is it stir copy? Stir dupe? Stern copy? No, because you don't have a buffer. You actually do need stir dupe, because stir dupe will allocate one. Yeah. Yeah. The source is the subpath, right? The link should contain the entire file path, right? Wait, I'm a little confused now. I'm almost positive that it should, right? Well, yeah, because this is the only place where the file name exists. So you'd want the full path, right? I think so. So max size, so it means it's totally safe to do name size here, even though that's one larger than we need. Should be fine. Okay, so now we have this dir link, and we need to add it to well, dir links. We need to deal with this align up. So in the kernel we're just using a compiler built in, but that's for Clang. I don't know if MSVC has align up. Is that a thing? Align. Yeah. What is it in the kernel again? Line up? Yeah. What was that align as thing? Yeah, that's what the I'm just looking for an easy way to do this align up. And MSVC, maybe, I mean, I could just implement my own. I'm just being lazy, trying to avoid that. Yeah, you can see here we're using Clangs built in. I mean, we could just compile with Clang, but I already wrote out all the shit in the build script. I mean, isn't it just... We don't even have to do that. We can just say, like... Do that, mod... Pick the name size, mod that. And if it's not 0, you add on the difference between that. Because we're aligning it up. Snap. So we can make a macro for that. I'm just gonna do for now. Well, these are all U32s. So if it was this, right? Align up some value to some size. Size is not a good name, but I can't think of a better name for this. Just come on, size. So take valmod size, right? And then if there is a remainder at all, then you want size minus remainder, because right. So in this case, it's the size is going to be 12. So let's say the value was 4. The remainder is 4. You want to add 8. So you do size minus remainder. So yeah, return. If there's a remainder, you return the size minus the remainder, otherwise you just return the value. And that's the line up, right? Unless I'm just being super stupid. Okay. I think that should work. Alright, so you've got the directory link. So after you've got all the directory links, well, now you can create a new disk image entry for this. I think we forgot to make a disk entry for the file, didn't we? We added an inode, but did not, in fact, add to entries. Yeah, what's in a disk image entry? Die. Disk image entry. Cool. Inode type. Did we not do this? Right, this is the disk inode, so that is type. Disk inode type. But this is inode type. Inode file. You have inode type, inode num, and path. Child inode num, and the path is subpath. Except we need to do this. Interesting that you're always gonna do that. You're always gonna use this, right? So we only need to allocate it once. We can share pointers to it, I guess. So what if we do this and then we say subpath is equal to this. Alright, now you have the subpath as an allocated string. So you can use that pointer. And then here, couldn't use it again. Okay. Cool. After we've inserted all of those, well, we're basically going to do this again. Inode dir. Inode num is inode num. Path. Okay. So let's see. This path coming in here, well, every time it recurs, it's been allocated right here. But the first time it comes from here, so we should be good to use it like that. Mm-hmm. I'll leave this up here for now. And now we have traversed. Supposedly. Does it compile? Nope. Disk dir. Because we changed it to that's true. Does that matter though? Can we just use it as a map? Where does this use? Yeah, we're already using them like that, so I say fuck it. We're just gonna use a buffer of links. Stern dupe is undefined. What? Define in string. String. Stern dupe undefined. I guess Windows doesn't have that. Oh, this is C23. Stir dupe? I guess we just use the dangerous one. We live dangerously. Disk image entry. Undeclared identifier? Conversion from size T to U32? Possible loss of data. Well, no. From size T to U32 again? Sturdy. The POSIX name for this item is deprecated. Instead, use the ISO C and C++ conformant name underscore sturdupe. This is some fucking Windows bullshit, but whatever. I mean, I could just say fuck it and do a... whatever. Write disk image must return a value. Okay. So we compile now. Should we see what's happening? Let's make sure we're calling it, traversing the dir and all that. Let's step through it. Remedy BG build. What do I call it? Disk image. And then let's pass it disk. That path. Let's just use the full path. Disk. Do we use a trailing dealio? Maybe? I don't know. So, where do we want to go? We'll just step through the whole dealio. We have one of those. Alright, we step into here. Should be 2. 1? Alright, it's the root, so it's 1, yeah. Cool. What we really want to do is get into here. So if we look at dir entries, there should be 3 of them here. Sorry, it's comma 3. Code documents, notice. So the first one is code. It's a directory, so we should traverse. Do I want to go all the way down or just assume that it works and see what happens? If I step, what happens? The child inonum for this is 2. Does that make sense? Well, which inode gets created first? The directory or the contents? It's the directory, so that makes sense. Alright, so we've got that. What are the dir links we have right now? Alright, dir links we have. We have dot, we have dot dot, and that's it so far. Dir links is for, yeah, we're about to add a new one. So boom, boom, boom. Now we have, ooh, this is broken, entry size is wrong. Yeah, I knew my lineup was going to be fucked. It just totally seemed wrong. Same inode, that makes sense, because the root, its parent is itself, that's fine. This, inode 2. The name size is 38. Entry size is 10. What would that be? Um, 38 mod 10. Sorry, it's 38 mod 12. Gives us 2. Which makes sense, right? Because 36 would go in there evenly, and you're 2 past that. So then you'd have, right, 12 minus 2, it's 10. You'd add 10 to that, so it should be 48. But it's 10. Link name size, 38. What? Did I just write it wrong? So the remainder is valmod size. Yep. So if that's greater than 0, you return size minus remainder. Otherwise, you just return the value. What? No. What? I guess we just have to step in and see. So let's back out. Let's look at line up. Just run till we first hit this. Value's 46. Size is 12. Right? We would expect this to align it up to 48, right? It's 0. What the fuck? Value is 46, size is 12. Ah, I'm fucking stupid. It's the value plus that. Although I'm still not sure why the fuck that's 0. That makes no fucking sense. Uh... Alright, rebuild that. So now if we run here... Oh, because we didn't step over it. That's why. 48. Yeah. So the whole... Yeah. That should fix it. Damn, it's raining crazy right now. This is like the perfect rain music. Holy shit. It's rumbling. I gotta go check this out. pretty wicked out there. Okay. So we fixed that, now we just want to make sure this whole dealio is working. So this should be in code. Now we popped out. Now we should be in what? What's the current inode number? 1. Alright, so yeah, we're back in where we were checking when we were stepping through before. This entry size should now be right. What was name size? 38 to 48. We hit a breakpoint. Non-user breakpoint. Realloc base? Wait, what happened here? We tried to grow a buffer and we failed? So traverse. So we were here. Documents. The new size is just enormous, so we fucked something up. So this called buff grow. Are we just like traversing forever or something? I think I know what it is. I think we're not ignoring dot and dot dot and our whole fucking... I think that's probably what it is. Okay, so this is what I think is happening. I'm suspecting... Well, actually, I don't know. Don't we ignore that in our reader implementation? Yeah, we're ignoring dot and dot dot, so it's not that. That was my guess. Well, let's just run it again. So it's just 2 calls to traverse, actually, so I should have known that it wasn't infinite. Is our stretchy buffer fucked? How do we get to buff grow? Buff push tries to fit. Oh no, is this our... Yeah, okay. I think I had to fix this. Let me look at something. Alright, let me check this. Buff fit. What? Oh, it's __ fit. Part's fine. Alright, it's not that either, so I'm a little confused what's going on. So we're in here, somehow calling buff push ends up leading to buff grow with a new element size. Wait, new length. Being outrageous. So, let's see, buff. Who calls buff grow? It's here. Actually, wait, this might be the thing I was talking about. I think I just missed that. Push. If one more will fit. Yeah. Okay, no, the thing I was thinking about was something else. So, buff push, you say, alright, will one more fit? So, by calling that, so the length plus 1. That's not happening. Still, my macros are fucking terrible. Can't fucking step through them. Can we just see what the fuck is up with, so hold on. This was from trying to add to inodes, so. Like, what do we have in here? Type 1, type 1. This seems right, because that's garbage, so it seems like we only put this many in. Like, one of them's reserved, so you put 2 in there? Two directories? Alright, where does buff grow get called? Here. New length is bufflin UB. Plus N. So that's really confusing because literally right here you take the length. Oh, it is fucked. Alright, I'm gonna step through. So the inode number is 1. Great. Alright, we go in, we're traversing again. Now it's 2. Alright. Ah! That could be it. Hold on. 3, this should be a U, but it doesn't really matter. Three, so that's fine. I mean, we can be explicit just for that. Alright, that's all well and good. Now we're back out. Sure. Got another one. I guess we traverse in there. This time we fucking shot up. I'm thinking that the buffer's fucking moved, hasn't it? Let's see. I'm also now wondering if it's a problem with buff menu. Still having the same problem. I've never had a problem with my stretchy buffer before, so that makes me think something else is going on, but... Alright, let's see. What's happening here? Alright, there's gonna be some stupid debugging, so I'm just gonna crank tunes for a bit. So this is the length and this is the capacity of the buffer. So if we can set a breakpoint at this address, like a data breakpoint, and we'll see who fucking is writing to that. I guess address breakpoint. Or no, I guess it's a processor breakpoint. This address, it's 8 bytes. Who writes there? Processor breakpoint hit. Where are we? Is this where we're at? Wait, where the fuck are we? Somebody just overwrote my memory. What the fuck? And it looks like... It's like Windows? What the fuck? I mean, whenever something like this happens, 99% of the time it's your fault. It's not, like, gonna be Windows, but why the fuck? Why are they writing my memory? What the fuck? I'm trying to step out of all these calls. Okay. That's not the address of inodes? Was that last time? Did I do all this based on what it was last time? That might be the case. Alright, let's make for sure. Alright, boom. Actually, hold on. God damn it. Breakpoints. Oh yeah, we can just do it like this. Address inodes minus 8. Okay, so if we back up... What the fuck? What is this? Oh, right, because it's minusing 8 entire inodes. We need to do this. I'm so confused. Why is clicking fucking everything up? Okay, that makes sense now, finally. Alright, so if we do minus 16, that gives us here. Now this is where we want to do the breakpoint. Processor breakpoint. It's the same thing. I mean, is this is a different thread? Okay. This is so fucked. Alright, I'm gonna stop while I figure this stupid shit out. I'll be back. Alright, we got the problem. I think I realized it right here. Alright. Turn this down. So whenever you have a stretchy buffer and you push onto it, right? If there's not space, it has to grow. And when it grows inside the macro, it like reassigns to the variable. So the pointer to the stretchy buffer isn't stable, which means that when you pass it to a function, like we've done here, this can change. And so, you know, you either have to assign back out of it, or what I think I'm going to do is just have inodes and entropy globals for this for now. Because why not? That'll save. That'll be super easy, so... we're just gonna pull these puppies out. I could do this in other ways. I mean, the whole point of using the stretchy buffer was to make this simple, and it costs a little bit of headache here just because it's like one of the only real major subtleties. I mean, the only reason anyway, we can just move forward with this. So, yeah. Where should we put them? All this garbage up here. I guess I'll just throw them right here. That's kind of a doozy. It's dumb. It should have been obvious right away, and I think I might even mention something about that pointer stability. I was like, but I got off track. Okay, so let's see what that's like now. This seems stable now. Okay, so let's see. What happens if we get to here? Okay. You know, directory, file, or wait. How is this defined? Directory, then file. So we have directory, file, directory, file. How many files do we have? One, two. Or 5 files. And four directories. Alright, so step 3. Alright, we're 3 levels in here. We're at notes. There's 1 file in notes, I believe. Yep. The inode. That should be 9 now. Get a disk entry for it. Dir data? Should probably just call that dir links. Dir data's empty though. Why is that? Oh, because it's a file, so it only has a path. Wait, what? Wait, one is directory. Wait. We fucked that up. Yep. That's not what you want. This is not a file, it's a directory. So, what does that have? Dir data? Which... dir links. So now that's what we have. Dir links. I fucking love the song. The greater force. Demagogue, decimate. Alright, that was fucking sick. Okay, so it's a little messy because we're dealing with those globals, but I think we're traversing those now. So now we supposedly have all the data we need to write that out to disk. So let's check out writing to disk. These ones we can pass in because we're not modifying them. Well, we're not gonna add any inodes or entries, but right disk image, it's right there. How does it not find the symbol? I mean, maybe I should follow this. Like it's either that or right disk image dir. Disk image right there. This could be disk image right. I don't like that for some reason, but I think it's just aesthetic, so it's probably fine. Okay, whatever. So I think what I kind of want to do first is just... actually I want to go through entries. Buff land of entries. I'm debating whether I should just go all out and do like a whole dumping function or just like quickly verify that any of this shit is valid. Let's just do this. I know numb. Build 1, 2, 3, 4, 5 files and 1, 2, 3, 4 directories. That makes sense to me. Alright, so roughly it's okay. So let's go. So what do we need to do for writing out? So we need to write into this format right here. So what we need to do is basically iterate through these disk image entries. Like the whole reason we have these is so it's like a flat thing that's like it's either a directory or a file, and it has all the data that's required inside of that struct in order to poke values that you need in the right places in memory. So writing the inode bitmap is going to be easy because since we're going to like just tightly pack it all into the inode table, so however many inodes there are, you just write that many ones into the inode bitmap. For the inode table, we can fill it in later because right now it only has the type. We need to calculate the size and the like pointers to the data region where the data is. That'll happen later. So here we're saying we're going to look through all of these like disk image entry. If it's a directory, we write to a write file. Okay, so for directories, what do we do? Well, you find the first empty data block, so we look through this bitmap, try to find, I mean, also because this is going to be sequential, you're just going to be looking for the first 0. It's all going to be in a row. But you find a 0, set that to end use, go to that data region, and then start writing the directory data there, which is just like the links, the inode name pairs. And then we need to go back and write this block address into the inode table. And also the size in bytes. So I guess when this is all done, we need to write size in bytes to inode table as well. That's going to be the same for files. Cool. I think now is the time where we switch to some different kind of tunes. These kind of tunes. Is that too loud? Hopefully not. Drop it a little. Okay. Okay, so disk image write needs to take a path to a file to write it to, right? And I guess we'll just write it to disk that image. And then I guess right there can just take file pointers. We just do that. Okay, so we're gonna have like, we're gonna open the file path for reading, for writing, binary because we're on Windows. We don't want none of that bullshit. And it's, oh fuck, I just created a new bullshit file. Every now and then that kind of shit happens. Hold on. Let's just delete that. Yes. Okay. Where was I? What the fuck? Oh shit, am I like behind my face? Hopefully you guys can see this. Alright. Yeah, it's been a while since we did file IO. Open! Yep. Okay. Yeah, so we just want binary because on Windows we don't want to do any of that translating. Well, I guess that wouldn't matter for... Yeah, you don't want to be dumping like carriage return new lines. Okay, so... Close the FP. And return. Right, this is what we want. But we don't have that. So there's a few things we need to figure out, like we need to know like where these regions are. So the question is, where should I define those? I mean, I could do pound defines or just variables. Does it matter? Is more easyable, customizable. I mean, we want the kilobytes macro because that's nice. For now, let's just do this. Kilobytes 4. Starts at 8. The data bitmap starts at 12. the inode table starts at 16. And the data region start is at 272 kilobytes. For now, that suffices. So let's write an inode bit. So we need to like you want one shifted up by however many inodes there are, and then you want to like flip that. I think, right? Because let's say all right, you had like 4 inodes. So we take one, you shift it up by 4. So 1, 2, 3, 4. Puts it there. And then you flip all the bits. Not quite. Oh, wait, no. You don't flip all the bits, you just do -1. Because -1 will then make everything below it 1. And then you'll have 1, 2, 3, 4 bits. So, yeah. So that's how you get... The problem is, though... this works for now because we have less than 32 bits probably. It's actually funny how like working at the bit level is a little bit difficult. Yeah, just thinking about the best way to do this, like the best, simplest way to do this. I know for now this will work, and you could just do that in a loop, like do this until you run out of bits to write. Should we tuck that behind a like... inode bitmap? Probably. Alright, so what do we need here? We're gonna need the file pointer and the inodes. Honestly, we just need the length of it. This is how many ones to write to. Yeah, also these are gonna need to be above this. Um, and yeah, all of these are gonna need access to these pretty much. So let's do this. Blam. Blam. Found define. Oh yeah, this has weird issues with putting nouns in there for some reason. Alright, there we go. Number of inodes. What should I return? The number of bits? I don't know yet. Bits written, bytes written. Nothing. I don't know. I mean, the write could fail, so. What is this? Okay. And honestly, there's no need for like signed by default is usually better. The only reason we're using unsigned here is like on this there might be a lot of this stuff, but anyway. It's definitely not gonna be, arguably maybe they should be in, but whatever. Okay. Well, num inodes is greater than 0. Well, you can do num inodes divided by what will fit in a U32? Oh, wait. Oh no, that's good, that's good. So basically what I'm going to do is in a loop say like write this many bits out. The most we can write at a time. Well, see, I've been doing U32 everywhere because the operating system that I'm running is 32-bit, but since this is a standalone program, we could do it in like 64-bit at a time, but since like, I don't know, we might want to at least conceptually in the future be able to like run this on the operating system to create disk images. You could stick to 32-bit. all it's going to do is change the loop iterations anyway. So to stay, we're thinking of a U32. So the bits the num bits is num inodes mod but that's in bytes. So size of U32 times 8, because that's bits. Right? So, like, it's so stupid. I mean, I wanted to signal this because, like, if you change the type, but let's just fucking write 32, honestly. So mod 32. But if it's 32, it gives you 0. Don't you need mod 33? Right? Because if you get 32, you want 32. If it's 33, oof, I'm a little sleepy. My brain is struggling with this. Right? Let's say there's 32 inodes. 32 mod 32 is 0. I'm a bit 0. That's not what you want. You want 32. What the fuck? Why is my brain like frozen? Let me move on because it's just the max value. It doesn't matter. We'll figure what that needs to be. But num news about 32. How many bits we have? So. Once again, you'll have a problem if that's 32, right? Because the max shift is 31, right? Because like if you had a 4-bit system, shifted by 4, 1, 2, 3, 4. So I think this is what you want. Yep. Although, hold up, because if you go... Yeah, if you go up by 32 minus 1, it gives you 31 ones. That's the most you can write at a time. So I mean, we could handle that case separately. So if it's equal, just manually do that. Otherwise, you do that. I bet there's a clever fucking bit hack way to do this. I'm a dumbass, so I don't know how to do that. Okay, so let's see. For the general case though, we've got a mask. Okay, and then you're just gonna like write that mask into the inode bitmap. So the first thing you can do, I suppose, is like seek, right? Seek to where you need to go. What is that? fseek? What's the difference in fseek and lseek? I thought that was a thing. Maybe that's... They call it origin. In Linux they call it whence, which I always thought was an interesting like term for it. Like whence. They call it whence. Whence. Okay. From... Wait, what is seek set? From the beginning of the file? Yeah. So you want to seek fp to inode bitmap start. Inode bitmap start seek set. What does fseek return? An int? We're just gonna assume it works. Should we check this fucking error? What does this do? Return 0 upon success. So if it's not 0, that's failure? I mean, we could just mirror that here, I guess, but... I feel like I'm gonna return like how much we wrote. Should we what? Just fucking say anything? Yeah. Let's do that for now. mask, we're gonna write that in, so we're just gonna F-write. I haven't done file OO in a while. It's just gonna be the file, the buffer, and the size, right? Not quite. A pointer to the data. Okay. Or should we just accumulate all this into a buffer? That's probably what we should do, right? And then do one write? Yeah, that's what we should do. So then we can do this, right? So once we've accumulated all that into, like, I guess we can do this. It's a bunch of U32s. $4K, we can put that on the stack, right? Average stack size is like 4 megs. Is it 4K or 4 megs? It's gotta be 4 megs, right? The default stack reservation size used by the linker is 1 megabyte? Damn. Well, it should still fit. 4K will still fit. Anyway. Actually... yeah, fucking whatever. So we're gonna be like... we're gonna write... buff. Ooh, that's an interesting question. If you... so what I'm wondering now is like, do I have to manually write zeros to like, do I have to zero out the entire disk image? Or will it be zero by default? Like, could it possibly be garbage by default? I feel like it has to be 0, right? What I'm wondering now is like, what happens when you seek like, I've just opened this file, which is like a new one, right? Alright, you create a new file. You're gonna destroy the contents. Huh. I don't know if I've ever tried this before, where you like open a file, like create a new file, and then you just seek like 4 kilobytes forward. Like, does it just write zeros in there? Or do I have to do I have to write all those zeros in and then seek back? Let's just do that. I don't fucking know. Well, I don't know. Does this tell you any more information about like... Okay, POSIX allows seeking beyond the existing end of file. If an output is performed after the seek, any read from the gap will return 0 bytes. Where supported by the file system, this creates a sparse file. But we're not in POSIX, are we? Let's check the Microsoft docs. Okay. This is for F-Secret. Okay, the pointer can also be positioned beyond the end of file. It clears the end of file indicator and negates the effect of any prior... Alright, when a file is over for pending data... Wait, what is that? Negates the effect of any prior unget C calls against the stream. Can also be positioned beyond the end of the file, but what I'm wondering is, does that do what POSIX does and write zeros in there? I think we're just gonna have to test it out and see, because we know at least on POSIX it'll work, and then we'll just have to test it here. We'll try it. And if not, then we can just fucking write out a shit ton of zeros, which would be retarded, but we might have to do that. What happens if we just, when we open it, we seek to here, and then seek back? Does that zero it out? What's the problem with this? Syntax error, missing F, seek, this. What the fuck is this? Whatever. I'm just interested in this. One 16656. Then we can seek to the beginning. What does that do? What do we think that's gonna fucking do? Yeah, it was 0 byte disk image, which makes sense. What if we... Wait, what? That's weird. What if we seek to the end? Man, F rate's kind of weird, right? So it's the buffer size count and then the file. Doesn't really matter. F right, buff. Buff, size, count. File. So if you write after it, then it might work. Yeah. Where the fuck did... There's a single 69 right there. The rest are zeros. So if you seek and then write, it will do that. Might be useful because then we can actually keep the data region like only as short as it actually... Well, but you actually need that space if it's a, like this image is going to be like a going in a drive. That's kind of cool. I didn't know about that. All right, so that many bytes minus 1 byte. And then it's gonna be a 0. Wait, why are there a billion versions of it? That's very weird. Huh. Oh, never mind. Okay. Okay. So, we have a 0. We write one out. Actually, yep. Yep. Then you seek back to the beginning. I mean, we're just assuming this works. All of these could fail. Yeah, it's gonna be gross. I'm just gonna assume this works, because it's just writing a fucking 0 to the file. And should I check all of them? It's annoying, but left right returns how many bytes written, right? As what? Size T. Actually, hold on. Counts. Is that gonna say it wrote 1 byte or it wrote like 16 megabytes? Um, what is this? Size T LOU or ZU? Size wrote ZU. Alright, expected to write 1 byte. B bytes. This is stupid. This is disgusting. Alright, we don't have a U8. So yeah, we should have a bunch of zeros. Why is it actually bigger than it's quite a bit bigger than 16K. Um, Actually, no, because that's in, yeah, it's that many bytes, because that's times 1024. Yeah, okay. So, yeah, supposedly that works. So now we can get back to actually writing this shit out. Okay, so Ah, that's why. I mean, this is way simpler than I'm making it, right? It's like, how many inodes do you have? Divide that by 32. That's how many, like, you need to make. And I don't have to allocate. Okay, so if you take inodes divided by 32, what do we call this? I don't know, iterations, I guess. And then you could say, so this is one that's gonna, I was gonna check operator precedence, but we'll just fucking do this. I just want to know now, I'm curious. Operator precedence, which one's higher between mod? Mod should bind tighter than not equals, right? There's mod. Not equals. Yeah. So we should be fine. So mod does in fact bind tighter than not equals. We just add another iteration if we have to. Thanks, Windows. And then we can just say iterations greater than 0. Yeah. But we need to catch. So this is just the cleanup. I've done this so many times, it's just like, um, The fuck is this formatting? God damn it. It's been a while and I think I'm like, why am I fucking this up? Okay, iterations is mod 32. Sorry, divided by 32. Well, it's greater than 0. Yeah. So these are the full ones. We don't even need to do that. It's just like, we can do a mem set, right? It has to be an ent though. How big is ent? 1, 2, 3, 4 bytes, 32 bits. So many ways to do this. I think I'm just gonna do the dumb one where you just iterate through. Am I missing something obvious? It's like, how do you put this many ones? Because I'm operating on the bit level and not the byte level. Like, all of this stuff is like built to operate on the byte level. All right, so this many times you're gonna write. One, two, three, four. Alright, now we do the remainders, so. now we can do the thing where we say alright, now you write the remaining bits. So now we seek to that position. Now we can do the F, right? Buff. Size of buff. One of those. FP. Yeah, we'll do that. Alright, so after we write the inode bitmap, yeah, my error handling scheme needs to be... I need to have one. For now, I'll at least get the error. Right. So we should be able to write an inode bitmap, assuming we can compile, which we can't. Let's type int and 64. Where? Is F right S size T? No. That's stupid. Okay. We compile. It's actually fine. So it knows that those are all zeros? Wait, where was this? Describe inode bitmap. Interesting. That's actually smart. Like, the system's able to recognize that there's all zeros and it doesn't write them. But, if we go 4K forward, is there a way to just like jump to an address? I don't like this editor. Anyway, okay. We gotta fix this anyway. So if you didn't write anything. Shouldn't do any, right? Because how many inodes are there? Just 10. Man, just 10. So what's the mask? Through FFF, so that's 8, 9, 10, that's 11. What? Oh, no, it's not. 8, 9, 10, right? Because 3 is 1, 1. So it's 8, 9, 10. That's 10 ones. The mask is right. So you wrote that many ones into the buffer. That's right. We seek to the start. We write those written 1. Why would you write 1 byte? It's confusing. It's at least 2 bytes, right? That's weird. Why the fuck did it only write 1 byte? Yeah, that's because of the assert. That's fine. I mean, is size of buff returning? What the fuck? So here, this is an array. Size of array should give me 4096. Count should be 1 4096 thing. Right? Size of each object. Size of that buffer is 4096. That, like, is my brain just fucking broken? This is crazy. It's 4096. Why the fuck does... Oh! It doesn't... The This is interesting. Fwrite doesn't return the number of bytes written. It returns the number of objects written. And since I defined one object of size 4096, it's telling me I wrote one object of size 4096. It's just kind of a weird interface. Okay. It's so stupid. This is like basic ass C shit. I don't know why I'm... So hold on, we can go back to like... Actually, no. Expected to write this many bytes, but wrote this many. Expected to write block size, but wrote written. Okay. Yeah, it's just that. Fuck. Why did I do that? Alright, we wrote the inode bitmap. Now you're at the... Is the music, like, annoying as fuck? Jesus, I need to eat some food. I keep going a little bit. Fucking hungry. If... entries. What the fuck? Right there. What does it take? The entry? Yeah. A pointer to it? Entry anotype is that, call it with that on the entry, otherwise, with the file. Incremental data blocks by how many written? Blocks. Sure. Okay, so that's the basic idea here. Block. Inodes, entries, and data blocks. So what do we do here? Another E32, or is this a size T? I don't know. Oh my god, I'm so hungry. I gotta get some food. I'll continue, but I gotta fucking eat. Alright. Tried to eat. I did eat. But I'm pretty fucking dead. I think the only thing I'm gonna be able to do is just write the super block. And not implement writing files in DIRs yet. I'm gonna have to do that tomorrow. But we can bang out this. So the super block is just a data structure. It's right here. Right? It's just, yeah. So my dog. That's funny. Alright. Alright. So, alright, super block. Well, we just need one of these super blocks. Well, I mean, we're gonna know everything de facto, aren't we? So, the magic is VSFS. Although, maybe we should tuck that into something. String literal. Sure. I mean, we could figure out the bytes for those. Oh yeah, because it's U32. So, god damn it. All right. V. Which one of these is hex? Second column. So 76. Oh man, and it's like, all right, this is stupid. What am I doing? What is it? Word for V, is that what we do? Is it something like that? Okay. What was I gonna do? Actually, this is the same. I was thinking there was gonna be a way in Python I could turn the whole thing real quick. I guess I literally just need... So... 76 is the V. 66. Or that's... Where's the S? 73. So that's VSFS. But when you write that, it's going to be Little Indian. So least significant byte first. So it's going to be this. So you need to like reverse it, I guess. So you need 73, 66, 73, 76. Okay. Alright, magic. Size and blocks. Just hard coded for now. Was it 16 megabytes? 16656. I should probably have megabytes, right? Sixteen megabytes. Divided by block size. Actually, that's a little bit bigger, right? Hold on. Yeah, it's a little bit bigger because of all the other shit over there, so it actually is this 16656 kilobytes divided by block size. That's how many blocks. Cool. Num data blocks is just num data blocks. Inode start is inode table start. Data start is region start. I try to move and I can't. 1, 2, 3, 4, 5 fields. 1, 2, 3, 4, 5, 6 fields. What? Magic size, num blocks, num inodes. The fear is so strong that it becomes me. We're gonna change this like so. I cannot jump. Alright. Another thing we're probably going to want to do is we need to make sure. Sorry if that was really loud. I can't really tell. I need to make sure this is packed. Like something like that, but on MSVC mode. Honestly, right now it's fine because these are all, there's not going to be any gaps, but that would be a smart thing to do. There's like a pragma for that, right? Pragma pack. Okay, yeah, so you can do pragma pack and then specifies the bytes to be used for packing. So pragma pack 4. Is that gonna be fucked because of the type def before it? Maybe not. Anyway. Um, okay. Um, so we just write this super black. You want to know how many bytes were written, right? Actually, in this case, we do want the one, right? Damn it, I always forget what this is. Size count, so size of super block, count 1 to here. So if we didn't write it, so we gotta seek to superblock start. I guess it could fail in that way too. Oh, that's still good. Okay. Otherwise, I guess we will do this. F-right failed. I don't know. Okay. Why would fseek ever fucking fail? I don't know. Alright, I need to go to hex editor. I was using ONO editor, but it's fucking expensive and I only had a free trial. Some other people recommended this IM hex editor, but it's fucking garbage. It's a piece of shit. I don't like it at all. I'm gonna try it again, just all I have right now. See, it doesn't fucking work. I opened it a second ago and it showed the fucking values here and now it shows nothing. Like, I just don't understand. Well, there, okay. Well. Seven, 6. Seven, 3. 3, 6? Isn't that supposed to be 63? And then 0, 7? Wait, what? What the fuck happened? We just botched that. VS something. So the F is what, 66? I think it was that. VSFS. Right? Okay. Magic is right. Size in blocks. 44 blocks. Does that make sense? 44 blocks. Each block is 4K. Does not make sense. Wait, is this the number? 68 blocks. Yeah. This many blocks times 1496. That's how much memory? Doesn't seem right. 68 blocks. We should be getting 16656 times 1024. That's how many bytes there are. Divided by 4096. We should have 4164 blocks, which is what we have. That's a 8. Okay, yeah. 4164. I was just looking at the wrong thing. Okay, that's right. For size in blocks. So hold on, is this writing in like 64? I'm confused because 1, 2, 3, 4. This should be 4 bytes. And then 4 bytes, number of data blocks. That's not right. No, my nodes 10 should be right. Inode table start should be 16K. Yeah, that's right. One, two, three, four. Yes. 1, 2, 3, 4. Yes. Num data blocks is 0? That makes sense probably because I'm not incrementing it. Yep. Yep. So that's fine. There's 10 inodes. Starts at 16K, and the data block starts at. That looks about right. Alright, we've written a super block. I need to see what 16K is. Uh, 4,000. Actually, wait, no. We just want to look at the inode bitmap. So if you look at 8K, what is that? 2,000. And that's... Yep. Chance! Stop it, bud. Alright. So we are in fact writing all the data we're thinking, so that's all I can do today. God, I wish I fucking had more time. Working a day job is fucking ass. But this is pretty cool. We gotta start on you know, writing out a disk image. You know, I think I fell into a number of stupid falls today, but we still made progress. Yeah. So hopefully I'll have time to bang out some more code tomorrow. Yeah, peace.